So this is a tutorial on using AI to kind of push your cluster around. We're going to cover probably a lot more about using AI in production than maybe I originally planned. Let's get introductions out of the way. My name is James Isles. I'm a principal field engineer at Solo. This is Michael Levan. He is a principal engineer in our AI group. We both, as you can see by our very purple shirts, work for Solo. So I'd like to kind of get this out of the way. What is Solo.io and why should you listen to anything I have to say? Whenever I do these talks, or I go and listen to other talks, I kind of think of the bias that people have. And I would like to expose everything that you should know about me in this case. I am a principal field engineer. What that means is I get contracted by companies to go and look at their problems and fix them. Prior to that, I was a staff SRE for a decade. I put Istio in production. I've done the Kubernetes microservice or monolithic microservices, which was a very fun year for me. That is all to say that what I do now is I get invited into many companies' infrastructures. I get to talk to them about their problems and what they see, which means that in the last year, I've seen the problems that people have run into for their AI plans in at least a dozen companies at this point. And so I'm not an expert, and I would say anybody who says they're an AI expert is probably kind of fluffing you up a little bit, not really telling the full truth. But I have seen a lot of places where companies really want to put AI into production, but they are running into issues. And I'm going to talk about some of the things that we do and that I have seen that fixes those issues. And the idea behind this is by the end of this tutorial, you'll understand what it would take to put something into production, what some of the things you should look out for, how easy it is, to be honest, and how difficult securing it is. So where did this whole thing come from? As I said in my previous job, I put Istio in production. One of the things I also did was build out a test harness. And I really had this desire that every application team would be able to run tests really easily, load tests against their app, because I didn't like, as an SRE, hearing the excuse of, well, it ran on my laptop like this. Like it took 20 milliseconds on my laptop with no cache, not pulling any data. And then you put it in production and realize, like, yeah, your P50 is 100 milliseconds. Our return trip on this query can't be, or this call can't be more than 80. And so I wanted to give the application teams the ability to easily test what the load looks like. And then, all services are not all made the same. Some services are returning a ton of data, some are not. But I wanted to have a simple way of doing that. In reality, what I made was a very tribal knowledge system that only I really knew how to run well. And application teams ultimately didn't really adopt it, particularly because it's frankly just brittle. Like, I can build out a Fortio load test system and give it to an application team, and unless it's part of their pipeline and is easy to use, the friction becomes so high that essentially no one uses it. And one of the reasons that I picked this is I know I can use AI to smooth that brittleness. Like I can smooth out the edges that were in place, because instead of having to essentially write a very complex shell script every time I want to do this test to determine what I want to do for a baseline and what my returns are, I can use an AI agent to kind of interpret human language to run a query and give me some results back. And the idea is eventually, you can put this into a GitHub pipeline or use it in various other places, as opposed to just having this thing that kind of rots on your cluster that no one ends up using. It really stuck in my craw that no one wanted to use it. I worked so hard on it. And now I have a kind of a better way of doing this. In the bottom right-hand corner, there is a link to a GitHub that has a README that has everything that we install and go over. This talk is roughly 75 minutes long. We will have time for Q&A at the end. A good chunk of that is theory, because it is a one-on-one talk, and I do want to cover the basics. Right now, I frequently get in these calls where there's like three I wouldn't say experts, but three people that know AI really well, and then there's like two other people that have no clue. And so you end up trying to talk to the people that are like really forward with it, and then you leave other people behind. And I know I feel that way. I suffer from imposter syndrome, like I think every other developer does. So I want to make this as from the very ground up. If you don't know anything about why people would use AI or how they would use it, by the end of this talk, you should understand what the components are, what you should do to keep them to keep them safe in production, and really understand what that all entails. So the state of AI in 2025. If you're a developer, you're probably having a pretty good time. Maybe you're getting a lot of pressure from your directors. Maybe you're getting a lot of pressure from your CTO. There's a lot of companies that are like, we're going to move into AI, we're going to move into AI, and there's all these great things you can work on. And I mean, I was a developer for a decade. I built stuff in Golang and PHP and Cold Fusion, which shows how old I am. Please tell me no one knows what that is anymore. And so, they are these wonderful tools, and you have this extreme pressure to move this into production to get that value. And right now, there is a lot of money being put into AI, not just from buying GPUs, but from overall the industry. There's a lot of people trying to do these, and the failure rate is quite high. I think yesterday at the keynote, it was noted as something like less than 5% of people's AI workloads are in production. And I think a big part of that is for everyone else that isn't on the developer side or isn't really pushing it forward, your life looks a bit more like this. And I will show you why in a moment. There is when we talk to customers, one of the most frequent things is there's some fast movers that are putting AI into production, and then there are a lot of people trying to figure out what to do about it, because this is the rest of what's going on. Shadow IT, MCP servers that are easily compromised, agents that have access to privileged information because no one's locking them down. And a lot of these, going back to who Solo is, and we are a cloud-native networking company, a lot of these are because people are not properly securing their AI workloads. And there's a lot of different ways of doing that. We will kind of address some of that. But from a networking perspective, things like, some of these would have easily been solved by running this through a gateway and using prompt guard. Some of them would have been easily solved by using a service mesh and isolating what the agents can speak to and what they can't speak to. Some of these are, and I hate seeing this because I'm old enough to remember what it was like to write stuff that would pull out SQL injection attacks, but some of them look just like SQL injection attacks, except instead of in a call, it's now in a prompt. There was one company that got compromised because they had built an agent. They didn't lock it down very much, and you could send a prompt to it with directory information. So they started doing .. And they realized, an attacker had realized that, I actually have the ability to go and pull out data from elsewhere in this S3 bucket it has access to, which means they basically could exfiltrate data that they were not supposed to have any permission to. So, I mean, these are all things that can be solved to some degree with networking, some degree with AI gateways, some degrees just some prudence. And in that same path there, I have some resources on this. There's a very good article from the Department of Defense that actually covers the things that you should think about. Some of them are the old school stuff that you've probably seen elsewhere in your career, which is cross-site scripting attacks, and prompt injection really does just look like, in some cases, people passing bad paths. Some of it is very new, though, and things like rate limiting and observability are becoming more and more important because of this. Let's see. So what do you do about it, right? What can you do about trying to secure these agents that you're inviting into your infrastructure? As an example, I'm building out a stress testing system. If you were to compromise this and had access externally, and you were of an evil mind, you could use that to DDoS internal services from one internal service to another. You could use that to start hitting external services and start running up my bill on egress and ingress. These are all things, because by default, if you don't control the agent very well, it will have access to doing those things. So it is something you have to keep in mind. And I'm going to use this fella as an example. Probably no one knows who he is, and I wouldn't be surprised. This is the Marquis de Vauban. Vauban was the siege engineer for France. If you've ever seen what's called a star fort, it looks like that, that's his baby. And people have been running and using star forts for defense for well over 100 years past his death. His mentality was, I can't just have a castle with strong walls. I mean, there's still people that in the year of 2025 that think that they can just protect their perimeter and they'll be fine. I can't just have a castle with strong walls. I need, different angles of attack and protection. I need trenches. I need different walls that have overlaying fire. He was like the godfather. Everyone talks about defense in depth. Vaban had that in spades, and he was extremely successful. And his pattern for forts and defense was used so much longer after his death. The early forts in America, same design. Now, I use that as an example for how you should think about defending your infrastructure in general, but in particular with AI, if you're going to do this, that means that you need to build out a structure that has multiple tiers of defense. Otherwise, you're kind of really going to be asked to be compromised. Now, the neat thing about Vaban was he wasn't just a siege engineer that built all these forts. He's also the guy that figured out how to break all of them. And he actually built out this trench system. And I love this as an example because he had to know both ways. And this same trench warfare system was used all the way in the 1950s. So it is the same concept here. If you're when you build out your systems, you should build them with such a level of defense that you also have the realization that by building that AI agent and giving it extended permissions, you're essentially kind of inviting almost a saboteur. So you need to concentrate and think about what it does and doesn't have access to, how you rate limit it, what you do with your stuff. To give you some real world examples, the easiest one, and this has happened to multiple customers, is they weren't defensive about how their API keys were set. So developers have their Anthropic API key, they get a lackadaisical, it gets checked into GitHub, and they have a $40,000 bill the next day. That happened to at least 2 of my customers. Also, the state of 2020 AI right now is if you sign up with Bedrock, if you sign up with Gemini, they give you all this access to easily add all this AI stuff for you. They don't give you a great deal of governance or authentication or understanding of what the users are actually doing. I don't think that's intentional. It's just the way their systems are designed. So you can end up with, I have an AI system, I gave it to my developers, our bills are really high, I cannot tell you why that is, right? Again, this is something that can be solved between gateways and basically auth control. But people have been rushing so fast to put AI in production that's kind of not been happening. I'm going to talk a little bit about, let's see, how am I doing? Oh, that's a little fast, but a little about components and terminology. Again, this is a 101 talk. This is written with the expectation that you've never touched AI before. And I know I've just said a bunch of scary stuff about it, but let's go through what these things are built out of, and we can show you kind of how to protect yourself.
Thank you, sir. Mm-hmm. Cool. All right. Who knows what an LLM is? Raise your hands, come on. Let's get interactive a little bit. Couple? Yeah? All right, cool. So I'll take it back a little bit, right? Before LLMs, before large language models, what did we have? Well, we had data sets, right? And those data sets could be anything from medical information in a database. It could literally be an Excel spreadsheet, right? So you could have an Excel spreadsheet, and I'm a car guy, so I could have an Excel spreadsheet of make, model, year, tire size, whatever I want, just literally in an Excel spreadsheet. And that could be a data set. And then what do I do with that data set? Well, I take a bunch of data sets that have similar data, right? Maybe it's medical, finance, automotive, whatever. And I take those data sets and I train them to create a model, I train the model on the data sets. Excuse me, sorry, I got a little something going on in my throat here, so if I turn off my mic, that's why. So I have this model, right? And how do I get there? What are the steps? Well, I'm using some training tool, right? So from maybe a CNCF, right, open source perspective, how many people have heard of Kubeflow? Ready? Okay, cool, yeah. So you could take Kubeflow and you could take a bunch of data sets, right? And you could train a model, and then you could use that model. What are large language models? Well, more or less the same thing, right? Except there's an emphasis on the large part. This is trained with lots and lots and lots of data, wherever that data is coming from, right? Maybe it's the internet, or maybe it's Reddit, or maybe it's books, or wherever it's coming from. It is trained on a massive amount of information. That's why you can go to any LLM, right, or AI provider, right, whether it's Anthropic, or you're using ChatGPT, or you're using Gemini, or whatever you're using, and you can ask it any question you want, right? Like, what's the best way to make a chicken parm? I'm Italian, so I like chicken parm. Or what's the best way to drive from point A to point B? You could ask it any question you want, and it'll have at least some answer, right? We hope that it's the correct answer, but you never really know, I guess. And then with that, right? Actually, I'm going to go in a little bit deeper here. So with that, you have all these LLMs, right? All these models, but how do you interact with these models? Well, think client-server architecture, right? So if we're thinking the model is hosted somewhere, right, on some server, you have a client to connect to those models, right? You're using ChatGPT interface, you're using some chatbot on some form of customer service, right? So like you're on some website, a little chatbot pops up, and maybe there's some AI stuff in there. Every once in a while, my Uber Eats order is not accurate, so I open up the help, and it's definitely AI, because I'm not getting the, the correct answers there when I ask. So with all of that, right, we have these clients, right, and we can interact with it. But these clients are, they can't go and deploy infrastructure for us, or they can't go and run a security scan, or whatever we want it to do, right? It does not take action. So then, what do we have? We have agents, right? So that's the next step in the evolution. So with these agents, it's doing the same thing as this client, right? In this case, the agent is the client, and that's the thing that's actually doing the work. So maybe you're using Claude Code, maybe whatever else you're using, right? You're using some agent to interact with your LLM of choice, right? So like maybe, for example, if you're using GitHub Copilot, you can interact with multiple different LLMs. You can use GPT, you can use Gemini, you can use Claude. If you're using Claude Code, you're obviously interacting with Claude models. So now what this agent does is it can go out to these LLMs, right? When you say, hey, what's going on with my pod, right? Like, why is my Nginx pod down? It'll say, okay, well, what's Nginx, and what's a pod, and what's Kubernetes, and yada, yada. So it's going out and talking to an LLM, right? And it's retrieving that information back. And then it can go and it can perform a particular action based on, hopefully, the permissions you give it. I'm going to keep clicking this button the wrong way. Yeah, go ahead.
A note on the overall landscape of what you can use to build agents right now. We are in kind of the glory days of closed source, giving you a lot of stuff for free, if not cheap. The agent kit is a good example. That's OpenAI's agent building system. NAN has their own. There's a few others. There's not a lot in the open source community. There's Kagent, which is something that we've been building and has a pretty great community behind it. Other than that, there's not a whole lot of other ways of doing that. I say that because it's kind of clear at some point OpenAI needs to make more money. NAN is going to need to make more money. Those are closed source systems, whereas Kagent is going to stay open source. We've donated already. Just keep that in mind. Like, maybe they are better, maybe they are not, but there's not a lot of things that are CNCF to build out agents, and we're going to be using Kagent for this. Again, we are an open core company. Kagent is one of our technologies. Again, I don't want to pull the wool over everybody's eyes, but right now, if you wanted to go home and do this and not have to worry about spending money, Kagent would be the way I would go.
I'm going to keep clicking the wrong button, by the way. All right, so the next step is MCP. Who here has heard of MCP? MCP servers, Model Context Protocol. All right, majority of people, right? I think that's the new hotness at the moment. And one thing that I want to say, and apologies if I get a little ranty, James is going to tell me to shut up if I do, but we are at a time in technology where things are arguably moving faster than ever, right? Like, I saw going from virtualization to, ESXi or Hyper-V or whatever hypervisor I was using at the time, right? Then I saw going from that to cloud, right? And then everybody moved to Kubernetes and yada yada. And usually we have like 2 years in there, give or take, to vet out this technology, right? To test it, to play around with it, to get all the rough edges out. In the world of AI, it doesn't really seem like we're getting that time, right? So we're building the tracks as the train is about a foot away, give or take. So with MCP, for example, and I bring this up because with MCP, for example, it's arguably the standard in terms of giving your agent or your LLM, whatever you want to call it, the specific tools that it needs to get the job done, right? It's now the standard, and it hasn't even been out a year yet. I think it's November 25th, everybody can keep me honest, that it'll officially be a year old. So like we are literally building the thing as we are ironing out the edges. And I say that because, to James's point, nobody is an expert in this space right now. I'm not an expert, nobody's an expert. We're all still kind of learning this as we go. So don't be nervous about the terminology. Don't be nervous in thinking you're behind the curve or whatever, because you're not. We're all literally just one step ahead. That's where we are. So don't be nervous about that. But let's go back to MCP. Now, what is MCP? So conceptually, I like to call it a third-party library. My background is in back-end software engineering and then platform engineering. So when I'm looking at a third-party library and I'm bringing in this code base into my application stack to extend whatever I'm building because I don't want to build a module or a package or a library for it, I bring in a third-party library. And I get that from an open source project or a vendor or wherever, right? I'd argue that MCP is very, very similar to that, right? MCP is either standard I/O, right, SCDIO, and it's either hosted on maybe PyPI or NPM, and you're bringing down this package. It's not being installed locally, but it's sitting in a cache, I'd call it. And it's literally just application code, right, underneath the hood. That's all it is. And then if you go the streamable HTTP route, which is the second option, that's actually hosted in a server somewhere, right? So you're calling down the tools via that server. A good example of this is the GitHub Copilot MCP server. It is sitting in some server somewhere. Okay, so that's one piece of MCP. What is MCP servers? Literally just functions written in JS or Go or Python, whatever way you're creating the MCP servers. Now, why is it important though? Well, what this application code is doing underneath the hood is it's giving you particular tools. So going back to what I was saying about LLMs before, they are trained on a wide range of data, which means it's not going to be an expert in everything unless you train an agent specifically to do so, or you fine tune it, or you implement a RAG, whatever you want to do. So what these MCP servers do is they expose tools, right? And these tools give us the ability to say, hey, agent, go look at these tools and become an expert, right? So for example, we'll go off the GitHub example. There are tools in there for listing branches and creating PRs and listing PRs and all that stuff. So maybe the agent or the LLM rather already knows about that, but those tools within an MCP server give us the ability to extend the agent's knowledge. That's the gist of it. Okay, so now we're going to move on to we can call it the security layer, right? If you want to look at networking, if you want to look at observability, if you want to secure how the connections are, right? You want to start with Istio?
Yeah, I'll start with Istio. That's my software. I work with Ambient Mesh quite a bit. John Howard actually had a very good talk yesterday about where Istio is with the overall AI landscape. And it's an emerging thing. I will say that service mesh is only going to get more important with AI workloads. In particular, the ability to observe and control what an agent does. So to back up, you've built your agent, it's using MCP tools. You need to know how it's accessing those MCP tools. You will probably want traces between the two so you know exactly what it called and exactly what it did. So the observability from a service mesh becomes more and more important. You'll want to have an understanding of the latency and how long those calls take, because that time eventually, in some ways, ends up being your cost because of its CPU usage. Extending into if you're one of the few companies that are running your own models and spending money on GPUs, you'll want to be able to control that spend and how things are routed to it as well. And then the security layer, of course, is also very paramount. When we talk about the way that identity works and the way that security works between agents and MCP and then the underlying workloads, there's kind of two things to think about. There's the actual workload authentication. Can this agent call this MCP tool from a networking perspective? Does it have the ability to do that? And are there authorization policies in place to allow it to do that? And then there's also a thing that is very difficult to do, and this has been driving proxy creators like John Howard crazy, which is, well, if you're going to have that MCP tool do something on your behalf. So if you have an MCP tool, like GitHub as an example, who's that going to act as? If it's going to act as me, what permissions does it have? What am I going to allow it to do? So that space has become more and more important, more than it has been in the past. In fact, when we talk to customers and we put people into production with this, we almost consider running a service mesh as almost a given. I will say in the last year, we've put a lot of companies into production with Ambient. It's very easy, so it's a little easier to say that's a bit of a given. But if you do not have those controls, if you do not have that security, if you do not have that observability, you're essentially kind of in the wild, wild west, and you may end up with another headline like I was showing before. It would not surprise me. Note that I didn't have anybody's company's names on there. At least one of them is a company I worked with, and so I don't want to have NDAs. I don't want to blame them for anything, but like it's very easy, and they're not dumb companies. They're very smart. So yeah, I mean, I would say that service mesh is just that much more important. The other two things on here are Agent Gateway and Kgateway. If you were at this morning's kickoff with John Howard, won an award for the most contributors, I can tell you a bunch of his contributions are to Agent Gateway. Agent Gateway is a proxy that is built from the ground up in Rust. It's extremely performant, but it's also designed to handle AI workloads and do things like that extended auth for MCP and the way we do that, and multiplexing and all these things that have come from the MCP spec. And more than just the MCP spec, there's going to be other specs that'll come along, UTCP or you're using A2A. All of these things now have requirements and gateways that didn't really exist with just the normal API gateway, which means there's a lot of technology that everyone's kind of used to is not going to work the same way. And we know we tried. Specifically, we were building out our AI gateway using Envoy, and we got to a point where we were running XProc for so many things that we realized it was just not going to be feasible, which is why we kind of pivoted towards this. I say that all to say is, this is how you secure that front door and some levels of depth, because you can run as a waypoint within Istio, so you get east-west security as well. It is extremely important. It is also a place that there's a lot of things changing. In order to keep up with the same specs, like MCP is a good example. Less than a year old, like 6 months ago, it went through a pretty major revision. So trying to keep up with that. Or even just this talk itself. I submitted the CFP, and between then and when I started working on it and realized I had to build this out for today, MCP changed by a huge amount. Agent Gateway became a thing. There's all these technologies that are moving so fast that it is important to keep that. The core concepts of network security that have existed forever are just as prevalent and important today as they were before, despite all those things moving. That isn't to say that those components won't move as well, but it is good to have that good base. Kgateway is, again, also open source. That is a control plane that we run in front of Agent Gateway. And not listed on here because it's more of an enterprise thing, is AI gateways. That is something that I think just about everybody offers in the gateway space, us included. With the realization that those workloads are different, becomes the realization that you have to build these different gateways, becomes the realization that if you want to run this in production, you'll need those. And when I talk about that, I talk about the things that do prompt guarding and some other stuff. Some of that is in open source, some of it is not. We'll cover what we have in open source.
Cool. Yeah, so a really important thing to remember, especially with Agent Gateway or any AI-related gateway that you end up going with. Conceptually, right, gateways were really created more or less from like a microservice perspective for stateless workloads, right? So you have stateless workloads and you're looking at headers. Not all microservices are stateless, of course, but I think that's where everything started, right? Like I remember just 2 years ago having conversations about you can't run stateful workloads in Kubernetes, right? But you can. Now, from an AI perspective, what that traffic looks like, right? So like, for example, I'm going from an agent to an MCP server, that's stateful, right? It's all about context, right? Being context aware. And it's it's looking at the response bodies, right? It's not stateless, it's not looking at headers. So keeping that in mind with any AI-style gateway that you go with is super important. And that's one of the big reasons actually why Solo built Agent Gateway is because for that particular use case. And then one more thing I'll leave you with on this slide is when you're looking at Agent Gateway and K-Gateway, K-Gateway is the control plane, right? It's the brains of the operation. So if you're sending, JWT auth configs or you're sending rate limit configs or whatever you're doing, you're sending them to the control plane, right? And then the data plane, the proxy, that's where Agent Gateway comes into play. So just as an example, if you deploy a gateway object, right, in Kubernetes, it's going to, and you specify Agent Gateway as the gateway class, it's going to deploy that data plane for you, that Agent Gateway pod. Do you have anything else on here? You good?
No.
Yeah.
So yeah,
Cool. Is that it?
it's in practice. Yeah.
Cool. All right. This is the demo part?
What's
Or
that?
this is the demo piece?
Yep.
Yep. Okay. Cool. All right. I know the Wi-Fi has been a little bit weird this week, so let's hope that this stays up. Start mirroring. Nice, okay. Can everybody see that okay? Do I need to zoom in? Thumbs up? Zoom in a little bit? Oh, I'd have to switch to theme. Let me see. Let me go to maybe, let me see. Let's see if I can get like some like light theme here. Give me a sec. No, it's all good. Let's see. Is this one any better? Nope. Is this one better? Yeah? All right, cool. Okay, so one of the things that I just wanted to start out with quickly within VS Code is what do agents look like when we're building them today, right? So like maybe you're using ADK, maybe you're using Crew AI, LangChain, whatever other framework you're using, right? So I want to go back to like client-server architecture, right? So what does it look like? So I have a client here, for example, I'm using ADK, Agent Development Kit from Google, right? And I'm specifying my model here. I'm specifying the Kubernetes MCP server, and then I'm specifying the tools that are available, right? So this is the client, and then what happens if I want to access my agent, right? Like for example, I want to host it somewhere, I want people to be able to access it. Well, then I would create a server, right? I would expose the agent card, that way it can expose like the tools and the functionality that it has. I would run it, right? And then I would host it on, not localhost like this one, right? So this is the client server architecture for interacting with and building agents right now. So for example, this is one agent, right? Can anybody, I think I can hear everybody. Can anybody tell me, like, let's say I wanted to do this 5 times or 10 times or 20 times. How am I gonna kind of think about scaling that out? Any guess is totally fine. Anybody in the front have an idea? Right. Right. Yeah, so I have to essentially scale this out 10, 20, 25 times, whatever, right? So that means I have this entire code base that I have to deal with, right? Whole bunch of clients, whole bunch of servers. So regardless of what agentic framework that I'm using right now, that's kind of what life looks like. And that's one of the many things, and in my head, this is the thing that always comes up, that Kagent actually helps us out with, right? So instead of thinking about this, from a, I don't want to necessarily say don't think about it from a programmatic perspective, but instead of thinking about it in like a standard raw client-server architecture like this, right? Think about it in the way that we manage Kubernetes workloads today, right? So what does that look like? It's all declarative, right? So it's not imperative, right? We're not telling it what to do and how to do it. We're just telling it what it needs to do, right? So we have a Kubernetes manifest. This Kubernetes manifest has an object in it. It has an API endpoint, right, for custom resource definitions. And then we're specifying in there what we want to do, what we want to deploy, where we want to deploy it, right? If it has secrets, if it has services, whatever it is, how many replicas it has, right? If we want to do horizontal pod auto-scaling, vertical pod auto-scaling, we want to connect a secret to it. Whatever we want to do, we can do that in the realm of orchestration with Kubernetes. So, my screen just went off. So why not do that with agents as well, right? Like, why not have agents that scale the same way? Why not have agents that can have secrets injected? Why not have why not have agents that, hey, I have one pod, I want to make two, right? Because it's on heavy load. I want to set, CPU and memory limits, whatever I want to do. So this is what we're going to be looking at today. I did the full installation already because my assumption is nobody in here wants to watch me deploy 8 applications and run helm install 8 times. So I deployed everything. This repo is publicly available, so you're welcome to go use it if you'd like. So I have a couple of things deployed here, right? I have everything from an Istio perspective, specifically Ambient Mesh. That's why you see zTunnel and the Istio CNI in there. I also have Kgateway. Remember, what's Kgateway? Kgateway is the control plane. And then I have Kagent and the CRDs, of course, that are needed, right? So the first thing that we're going to start off with is we're going to dive into a little bit of what Kagent can do. And I want to say that I like this demo just because I think it's cool, but I want to make it very clear that Kagent is a place that you run agents, right? It's not just for Kubernetes. It's not just for Kubernetes agents. If you're, in the finance world, right, and a couple of folks come to you and they say, hey, we need a day trading agent, right? You can host it on Kagent, right? Just like any other workload running on Kubernetes. Every workload on Kubernetes isn't Kubernetes specific. It's for whatever application you have. So. That's Agent Gateway. Yeah, 2 pieces of the puzzle. So Kagent is how you host and run agents. Agent Gateway is networking, security, observability between agents to LLMs, agent to MCP server.
So that's more than Kagent.
Yes.
And Kagent is again?
Sorry?
What is
Kagent? Kagent is how you host agents on Kubernetes, right? So going back to the client-server architecture piece, right? So instead of writing your agents like this, hosting them in whatever server, behind whatever ALB, thinking about, how am I going to scale this thing out? Instead, you can do it in Kagent. By the way, feel free to interrupt if you have questions. You don't have to wait till the end. Okay, so this is what I'm going to do. I'm going to take a pod that's clearly going to fail because you can see the latest tag here, right? So it's going to fail, and then I'm going to ask Kagent, why is this thing failing, okay? So let me go over to VS Code here. I'm going to go ahead. I'm going to copy this, and I'm going to deploy it, which it's going to fail with like an error image pullback. I think that's what it's called. All right. Do a kubectl, get deployment. All right, kubectl, get pods. All right, our image pull. All right. So now what I'm going to do is I'm going to prompt Kagent, right? Now, there are two ways that you can interact with Kagent. You can use it via the CLI, the command line interface, or you can use it via the UI. I'm going to show the UI just because from a visual perspective, right? So let me go ahead and pull this up. Let me zoom in here. I can turn this onto light mode. All right, so this is the UI for Kagent open source, okay? So now what I can do is I can go to, these are all agents that are pre-built in, by the way. You can turn them off if you want to, but these are the agents that come with Kagent out of the box, right? So you have some Cilium pieces here, you have some Istio pieces here, observability, et cetera. So what I'm gonna do is I'm gonna open up the K8s agent, and then it looks a little squished just because I'm super zoomed in right now. But if I run this, right, I'm gonna hopefully it's gonna tell me, right, if my LLM wants to like me today, hopefully it's gonna tell me what's going on within my environment. Now, one thing that I wanna point out, notice on the right here, we have all these tools. These tools are coming from an MCP server, right? So this is the Kubernetes MCP server that we can use to make our agent an expert in Kubernetes, right? So these are all the tools here that are available. Now, fun fact about MCP servers, right now the general rule is you don't want to use more than 15 to 20 tools within an agent. So like some MCP servers, for example, have 40 tools, right? Instead of saying, hey, I want to use 40 tools, you want to limit it to around 15 or 20. The reason why is because of hallucinations. A lot of people are saying that if you go above 18, 20, you see more hallucinations, which makes sense, right? Because your brain can only hold so much information, right? So can an agent. All right, so we're going to go ahead. We're going to run this. All right, my internet is doing good still. Okay, so notice here how it's calling. Oop, going too fast for me. Notice here how it calls K8s get resource, right? And that's calling the tool, right? So that's one of the MCP server tools, okay? And then it's calling a ton of other tools as well. So it's pretty much going and troubleshooting for me. It's gonna go through the get resource tool, the describe resource tool, the apply manifest, et cetera. Now, if we scroll up, we can see what is going on here. So I'll help you investigate the pod. First, let's go through image pullback status, and then it gives me the output here. So if I want to fix it, here's what the typical deployment would look like, right? So it's essentially saying it's failing because of the tag, right? So let's see if it'll do this for us. Can you apply the correct, if I can type, configuration per the above? Right, here's the correct configuration I'll apply. I'm looping because, yep, okay. So I think I'm cutting in and out here. So, okay, I'm just gonna go ahead and cancel that, that's fine. But point being is, it was able to tell us, okay, this is the issue within your environment. It was just the, Nginx latest container image tag, okay? All right, so the next piece in here that I will show is from an observability perspective. So I routed traffic, right, from my agent to an LLM. Now, one of the questions that I have been getting a lot, probably the past 3 weeks or so, is how do I know what data is going back and forth, right? Another big question that I keep getting is how can I limit or at least understand and know token usage, okay? So I have an agent, and people are hitting this agent and they're using it, right? But like, I don't know token usage on that agent. I don't know what LLM it's hitting, et cetera, right? So those metrics, those traces, rather, are very, very important. So I'm gonna spin up Kiali here. You open up this dashboard, log in, maybe. Internet is slow, apologies. Okay. But I can see right off the bat, right, here's a little bit of a graph, and if I click on the Kagent tools, I can see just a couple of things here, right? So like send traffic, retrieved traffic, right? So again, being context aware, right? Being stateful, things are being sent back and forth, especially when you're asking questions and then it's giving it a response, right? So you're going out to the LLM is coming back. You're going out, the LLM is coming back. Okay? So these are a couple of things that we can see within Kiali just by default, right? So this isn't like, I'm not setting up Prometheus and Grafana to collect metrics. I'm not setting up like Loki and Tempo for logs and traces, right? I'm not even deploying anything really extra here. This is just stuff that we can see automagically. Close out of that. Sorry, say that again? The number of tokens? Yeah, so with Agent Gateway, there is a metric called Agent Gateway _gen_AI_ token _usage _sum, I think. And you can see the amount of tokens that were used, the LLM that was hit, all that information. Yeah. Good question. Apologies, I can't hear you.
Why can't we use Langsmith to trace out every single interactions with the LLMs?
Lang chain?
Langsmith.
Langsmith.
Langsmith is from Langchain.
Yeah. So the question is, why can't I use Langsmith to pull out, like,
OpenAI SDK
right,
inside my code and just 2 lines of code
right.
I can send out traces and do Langsmith.
Yeah, so the question is, why can't I use Langsmith to pull out the traces, right? And yeah, you absolutely can. Why not? Yeah.
K-agent that we're experimenting
Yeah.
is on one cluster.
Yes.
How about if I want to do it for multiple clusters? Do I have to go to all UIs for all clusters?
Yeah.
Is there any way like a control plane cluster where you can manage other clusters?
Yeah, in the Enterprise Edition. Yeah. I know you didn't want that answer, but I'm being honest with you. Okay, so the next piece here, right? So we used Kagent to deploy, fix, or rather tell us what was going on, right? And then we knew what was going on, now we can go and fix. The next piece that we're gonna use is the load generation piece, and James has another piece on the load generation, but I'll do a quick demo here for this one as well. So I'm going to deploy an Nginx container image. I actually have to, it's right here, I have to push my changes to my repo. So I'm gonna deploy an Nginx container image, right? And then I'm gonna deploy a Fortio pod, right, to test against resiliency. And then I'm gonna send some traffic to it, and we're gonna ask it, can you investigate and hopefully fix the issue, right? Again, we're gonna test out the non-deterministic nature of an LLM here, all right? So let me go ahead, I'm gonna pull this config, I'm gonna apply. All right, let me just make sure this is looking good. CTL get pods. All right, should be creating. Okay, cool. So while that's running, I'm gonna deploy the Fortio pod. All right. And if you're not familiar with Fortio, by the way, it's just a load testing tool. Let's go ahead and run this again. kubectl, get pods. All right, cool. So all three are running. So now I'm going to open up another terminal and I'm going to send some traffic. Okay, cool. So this is connected. Now notice I intentionally set my resource limits for CPU and memory pretty low, all right? So let's go ahead and ask. I have a fair amount of load hitting my demo app deployment right now. Can you scale it up for me to avoid performance issues? All right, so I'm gonna go ahead, I'm gonna pull this. I'm gonna open up Kagent. Go home, I'm gonna start a new session here. right? And I'm going to go ahead and ask it. Let's see what it says. I semi-tested this, so we're going to see what happens. So it's going to go, it's going to get the resources, and then it's going to say, I'll help you scale up the deployment. Right? I'm having an issue encountering the demo app deployment. Look in kubectl, get deployments. I think that's what I called it. Let's see. kubectl, get deployments. Yep, all right. Let's see. Okay, it sees the Nginx deployment, so it's actually correcting me, because it is an Nginx deployment. All right, so you'll see it's going to use the Kden's patch resource tool to scale this up for me. All right, it's going to verify the current state. If you'd like me to scale a different deployment, all right, let's see. I noticed you mentioned demo, but I couldn't scale the deployment from 1 to 3 in the Kagent namespace. Okay, so now let's see if it actually did the thing for us. kubectl, get pods, namespace, Kagent. Okay, so, all right. So I wasn't very clear with what I needed it to do. Notice it did, in fact, spin up some Nginx deployments for me, and it did scale it up for me, but I wasn't specific in saying that I need to do it in the default namespace. So in this case, it's 1 for the LLM and 0 for me. All right, but nonetheless, it did what we needed it to do. We have 10 minutes left. Okay, James, you want to come up and do your piece? All right. Cool. Oops.
Hopefully that's fairly, yeah, it should be, expand that a little bit. All right, so we've talked about all these components, and just to reiterate what I'm doing here, and you can, I'll put the repo up again at the end. So what this does at this point is we have, well, in this case, if you go through the README doc, you'll have a service mesh in place, you'll have a gateway in place, you'll have Kagent in place. Now, you can build an agent, you can give it instructions, it's going to call out to an LLM, interpret those instructions, and turn that into things to do. But there's a lot of things it can't do, which is why we do MCP tools. In this case, I have a Fortio MCP tool, and it has several functions within it. Check service health, create load profile, echo, get service endpoints, list namespaces, list services, parse test results, and run load test. Now, this is a pretty simple one. I have 2 different sets in here that kind of goes through what you can do with this. For those that don't know Fortio very well, it is a very good load testing system that you can generate and say, like, give me X number of QPS and with this throughput and with this size packet. And then it gives you back usually some parse results in YAML or in a graph. Now, in order for an agent to do anything with that, it has to have something it can actually execute against. In this case, these are the functions that it's going to run across. I am running this as MCP servers. And you can see there's this Fortio load generator. Cool, so I've got that piece, but I actually have to have an agent that does something with it as well. So I have this Fortio load piece. I'm not very descriptive, so I just call this Fortio, Fortio, Fortio. And then within here, and this is the hard part, or at least it was for me, figuring out how do you prompt this to do the things you want it to do. So there's all these available tools that you have to list. Again, this comes from the MCP tools. What the workflow is, use list the services to decide what you can access, check their health, to see what you can also do some basic load testing. There's an advanced set of prompts as well. In this case, it's like, hit this name, hit a service with like 30 seconds. And then there's light load, medium load, heavy load. The idea being you can run any of these. And then there's some safety guidelines around this, and there's some examples. I think there's this kind of thing where everyone's like, oh, I can just have AI do it. But yeah, you got to know what the AI is supposed to do. When I went to write out this context, I used Claude. But I used Claude and said, go reference all the load testing I've already built, with all the documentation I've already built, and all the shell scripts I've built in order to get this. And that's kind of where this goes. Now, I've had a pretty high failure rate on this. I think I've actually hit my cap on my key. So we'll see if this works or not. Let's see, list services that I can run a load test against. Yeah. That's what I was afraid of. All right, so normally this would be writing out a load test within Fortio. I have an example in the doc. Sorry to say, I got panicked earlier and I ran this test a bunch of times in the hallway, and I don't have an unlimited Anthropic API key. And I've definitely hit my cap, and short of finding a way to put a bunch of money in it. This is the downside of AI. I don't have an easy way of running this. However, the doc that's here goes through all this. There is and within that GitHub repo, there's also how I built this MCP server, because I don't think anyone has actually built an MCP server for Fortio. It also covers how you lock these things down, how we do throttling, I believe, because we didn't get to that just yet, and a few other sections. With the few minutes I have remaining, if you do have more questions, we are going to be at the MCP Agents community party, myself, Michael, and a lot of other people from this community. I would say open up that, you know what? Yeah, I'm going to change my slides right now while everyone's looking. If you open up that doc, I have contact information for myself and Michael as well. Please come ask me questions, scan and give me feedback. You can tell me how I should put an extra $20 in my Anthropic key next time. Certainly it'd be good advice. If not, you can come talk to me. I will be down at the solo booth as well. Yeah, well, we have time. I would love questions from anybody. If anybody else, yeah, go for it.
Yeah, that's great. So I have 2 to 3 questions. So I'll start with the question, and then let others talk, and then finally
Sounds good.
So with reference to this K-agent, agentic AI, and some other connected, so where do you get all these tools from? How did you learn about these tools?
The question is with reference to Kagent, where do you get all these tools from? Where do you learn? So the neat thing about the MCP tool community is people share their tools all over the place. I wrote the Fortio one because it didn't exist, but there's one for like K6 and a whole bunch of other things, and you can pull them down. They end up being, like container images with some simple instructions and how you run them. And then within Kagent, as you saw when I built out that agent, at the bottom there, you can select the ones, again, as Michael pointed out, you don't want to do too many because you're now giving such a wide context to your agent. It's going to have a billion different questions. So you kind of want to limit it to what it needs to do. But then that container itself, again, that runs as a workload, which means you can secure it and do all the other fun stuff with networking.
Yeah, you also explained the answer. MCP community is the one word answer. Can you please share the MCP community?
It's in that doc that's in the bottom right corner. I'll add more stuff there. But to extend that same thought, one of the things we announced yesterday was agent registry. So this is a problem with like NPM and every other community, right? You need to have some level of control and understanding of what each one of these MCPs do. One of the security incidents that happened recently was someone built an MCP tool that was somewhat popular, and in there it was an email tool, and in there it BCC'd every email that went through it to someone's private account. Again, security is important. You should be blocking ports and any other thing that it can connect to. The reason why things like agent registry are going to be more and more important is just as you would have a container registry or any other registry, and especially when you want to understand the supply chain of what gets into it. That's becoming more and more important here as well. Do we have any other questions? All right, go ahead.
So with the K-agent, how would you prevent people from, like we had the issue of scaling out the deployment. How do you prevent other people scaling out somebody else's deployment?
The question is, with Kagent, how do you prevent basically bad actors that have access to your agent? Like in Michael's example, like he wanted the agent to scale up Nginx and scaled out something else because it had permissions to. And that is actually something that is fairly dangerous. I have my misgivings about the Kagent agent and the MCP tools it has, because it has a huge amount of access and privilege. Within Kubernetes, you're like, this shouldn't be able to change RBAC or change CRDs. There's this design and desire in a lot of demos, and we did this now, where it's like, we're going to have this thing fix something. That terrifies me as someone that ran this stuff in production. I don't ever want an agent to take actions that it thinks are correct. I want it to tell me what it thinks it should do, and I will happily say, yeah, that's a good idea, that's a bad idea. And that goes down to like how you prompt things, what level of security they have, what access you give it. There's a great deal of power. Within the Kagent community, there's a guy named Dimitra that built an SRE dashboard, which I love. But it is, a lot of it is read-only, with clear intention to make it read-only, because you don't want it to have things, the ability to delete, say, your log system or anything else. And I joke about this. Think about what Claude is trained upon. Claude is trained upon a lot of data from things like Stack Overflow and GitHub and Reddit and the rest of the internet. You know what you never see on the internet? You never anybody say, you know what, I don't know, I have no idea, I'm wrong. Do you think Claude is ever going to give you an answer that's like, I got no clue, sorry, try again? It's going to give you an answer every time. I harp on people, and I do this myself, anthropomorphizing agents, where you're like, come on, buddy, you can give me a good answer. Don't. It's not a human. It's not a child. It's not anything. It's going to give you an answer with low confidence you won't notice, or an answer that is insane. So you take his recommendations. Claude's smarter than me in a lot of places, but I don't let it do things unless I'm explicit about it and intentional.
We also have something called, So to that point, we have something in Agent Gateway called prompt guards. Okay, so again, like thinking about Kagent, this is the way that you're running agents and hosting agents. Agent Gateway is the way that you're securing that traffic. So there's something called prompt guards. It's in the open source Agent Gateway piece. You can see it in the docs, and you can put in there specifically to say, like, if somebody says in their prompt, delete, deny that from happening. Yeah. So definitely look at prompt guards. Right.
Yes.
Exactly. Yep.
Guardrails.
100%.
Yes.
Yep.
Any other questions? If you're shy, you can just ask me later. Or come to the party and ask me. The nice thing about doing these talks is I'm not like in front of a customer, so I can kind of say whatever I want. Like, I will give you my 2 cents on seeing this stuff in the SRE world, as I did that for a good, very long time. I mean, I think it's really neat. Like, there's a lot of power behind, like, again, if you go look at Kagent and like the SRE dashboard, there's so much neat stuff you can do that was always toil for me. Writing shell scripts to parse through log after log after log to chase down a 503 that was intermittent, and then to go find what service was calling it and why that was. Like, all that stuff, the machine is way better at than I am. Again, there's that saying is a machine can never be held responsible for its decisions. Therefore, a machine should never be able to make a management decision. I think that's true for SRE in the SRE world. I think that'll be true for a while. Not to say there isn't a lot of toil reduction there to be had. Just it does worry me that people will let it do things. There's a great example of someone who is vibe coding an upgrade to their database, and it's just like, I want to join all this stuff, and it's like, cool, drop these tables. They're joined now. I mean, they're empty. Like, you're gonna get really good performance, but like that's not really what anybody wanted. I think we're at time. But yeah, feel free to come contact me. I have a very unique name. If you look up James Isles, I'm one of all in North America, so I'm pretty easy to find. And I would love to talk to you and answer any questions. I'll be down at the solo booth as well.
Thanks, everybody.
Thank you very much.